Paul's lesson 10 assignment was to use a potentiometer to change the brightness of an LED using the Raspberry Pi Pico. I'm using the same setup that I used in lesson 6. Even though lesson 6 was using 3 LEDs, this lesson only requires the use of one of those. I'm reluctant to tear down a circuit I've already made in case I need it in the future. In this case, the red LED is connected with this jumper to GPIO pin 15. The negative side of the LED is connected through this 220 ohm resistor to the ground rail. The ground gets its ground from the Pico on pin 38, physical pin 38. Physical pin 36 is the 3.3 volts, and that's jumpered to the positive rail. The positive rail is where the potentiometer is getting its 5 volts, and the other pin, the outside pin, is connected to ground. The signal that the Pico gets is jumpered to GPIO pin 28. The solution to this homework assignment is to use pulse width modulation that Paul covered in lesson 9. I'm not going to go through that entire procedure all over again since that was already done earlier. In the solution for this, I have 2 libraries imported. One defines that we're using the pulse width modulation mode, and we're using the pins on the Pico, and we're also using the analog to digital converter port, or one of them. The pulse width modulation pin for the LED is GPIO pin 15. And these 3 lines define what's necessary to do pulse width modulation. I'm not going to go through that procedure again since that was already covered in an earlier lesson. The potentiometer is connected to pin, or GPIO pin 28. And the variable to get that receives that signal is called my pot. Now, both the input and output are unsigned 16-bit numbers, binary numbers. So all I've done here is I read the value that's input from the potentiometer, and I turn around and then output that to the LED. And then I print that or display that value down below. I sleep for 1/10 of a second and do that again. So let's take a look to see what happens if we run the program. If we run the program, right now I'm at a very, really I'm at the minimum value we can get. And you'll notice that at the lowest, if I look at this, I can't turn it anymore clockwise, but it's still flickering a little bit. You'll see that flicker. And as I turn it counterclockwise, you see the LED begins to get brighter. And it keeps doing that until it's all the way to the other end on the potentiometer. I can't turn it anymore counterclockwise. So let's go back to the dimmest we can get it with this program. If we look at the at what's being output down here at the bottom, you'll see that it never goes to 0. It's always some value normally in the mid 250s or the mid 200s, but sometimes I see it going down even below 100, and I have even seen it go above 400. So that's the problem. Because of electrical noise, we never quite get the output from the potentiometer to be 0. Okay, let's take a look at solution 2. You'll notice that the first 10 lines of this code is the same as in the other code. So I'm not going to go through all of those again. I've already done that. But in this case, I'm going to be working with volts, or the maximum voltage we can have is 3.3 volts, and the minimum is 0. The maximum value that we get from the potentiometer, the maximum is 65,535, and the minimum, as we said, as we noticed before, varies, but it's normally in the mid 200s. So I'm going to say the minimum value is 240. So if we were to plot this line, we would see that we have a y-intercept not of 0, but of 240. So if we start taking our readings, in line 18 we read from the potentiometer. From that we calculate the voltage based on the slope of the line and the value we've read. And I've rounded that off to 2 decimal places. Now when the value goes below 240, we will get a negative number. And negative numbers aren't working very well when we convert that to a positive or an unsigned binary number. So I check to see if it's calculating a value less than 0. And sometimes it even gives me a negative 0. I'm not going to go into the discussion on whether or not 0 is signed or unsigned, but in either case, I'm going to force the voltage to 0. And from that, we then calculate what the voltage is based on my voltage, or what the, not the voltage, but what value we're going to be outputting to the LED. I display that information below, and then I output it, and I sleep for 1/10 of a second. So now let's look to see what happens when we run the program. When we run the program, we're turned all the way down as far as we can go. And you'll notice it's not flickering anymore. But if I start to turn it counterclockwise, it gets brighter and brighter and brighter, until I've gone as far counterclockwise as I can go. And let's go back down to the minimum again. If we start turning it clockwise, it gets dimmer and dimmer as I turn it, until we hit the end and it's all the way off. So that's what we can get with this second solution to this homework assignment.